Good morning everyone. I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the problems, solutions in question bank of Module 1, which is first order and first degree differential equation. In Part B, this is the second video. So we have Part A, Part B, Part C. Already we have discussed in question bank Part A first video, Part A second video, and Part B first video also we have discussed. Now I am going to discuss the problems in Part B. Now we see one by one and we directly solve the problems which are in first order and first degree differential equations. Right? So see the first problem. Solve the differential equation x into 1 minus x square dy by dx plus 3x square minus 1 of y is equal to x cube. So this is clearly a first order and first degree differential equation because it is containing dy by dx only, that is first order and first degree derivative. So to solve this equation we can use any method which are available in the solution set: variable, separable, homogeneous, non-homogeneous, exact equations, Bernoulli, linear equation. Here clearly it is a comes under linear differential equation. What is linear differential equation? If the given equation is in the form dy by dx plus p of x into y is equal to q of x, then solution can be written as y into e power integral p dx is equal to integral q into e power integral p dx plus c. So this is the solution of the given differential equation when the given equation is in the linear form. So now first I have to reduce this into linear differential equation form by dividing throughout the equation with x into 1 minus x square. First write the given equation. The given differential equation is x into 1 minus x square dy by dx plus 3x square minus 1 by x into 1 minus x square of y is equal to x cube by x into 1 minus x square. Or I can write on dividing throughout the equation with x into 1 minus x square, we get dy by dx. This will be eliminated. 3x square by x into 1 minus x square of y is equal to x cube into x into 1 minus x square. The given differential equation and rewriting. Now, clearly this is in the form, this equation is in the form dy by dx plus p of x into y is equal to q of x. The right side is pure function of x and left side dy by dx plus p, this is entire function is p of x into y is equal to q of x. So what here, where p is equal to, what is p here? 3x square minus 1 by x minus x cube, and q is equal to, so the value is x square by 1 minus x square. This is q, the right hand side function. Now to write the solution, we need e power integral p dx. Consider e power integral p dx, that is e power integral 3x square minus 1 by x minus x cube of dx. Now you can observe that on differentiating the denominator, x minus x cube derivative 1 minus 3x square, or I can write it as minus of 3x square minus 1. So I can write it as e power minus of 1 minus 3x square, I'm taking out minus sign, x minus x cube of dx. So now it is in the form e power integral f dash x by f of x dx. X derivative 1 x cube derivative 3x square of dx. Now what I can write, e power minus log of the denominator x minus x cube, or this is log e power log x minus x cube whole power minus 1. Or this value is e power integral p dx value is 1 by x minus x cube. Call this is equation number 2. And the given equation is equation number 1. So e power integral p dx value already obtained. Now the solution, therefore, the general solution is y into e power integral p dx is equal to integral q into e power integral p dx plus c. That is what is, that is y into e power integral p dx means 1 by x minus x cube is equal to integral q. What is q? X square by 1 minus x square. X square by 1 minus x square into e power integral p dx 1 by x minus x cube dx plus c. That is integral x square by, so x on taking outside, you'll get 1 minus x square. And here 1 minus x square, already one term is there of dx plus c. Taking out x, you'll get 1 minus x square. So x cancel. Integral x by 1 minus x square whole square of dx plus c. On the left hand side, it is y by x minus x cube. Now what I have to do is to integrate this, put 1 minus x square is equal to t. I am going to use the substitution method to evaluate the integral. Then minus 2x dx is equal to dt. Or what is x dx? X dx is equal to minus dt by 2. So now the right hand side part will become minus 1 by 2 into t square into dt plus c. So here minus already there, dt by 2 instead of x dx. And here it is 1 minus x square is t, it is t square. So minus 1 by 2 into 1 by t square. What is 1 by t square integration? T power minus 2 plus 1 by minus 2 plus 1, that is minus 1 by t. So minus 1 by t plus c, or 1 by 2t plus c, or that is 1 by 2 into t means what? 1 minus x square plus c. And on the left hand side it is y by, what on the left hand side I will write here. On the left hand side you have y by x minus x cube. Therefore what is the final solution? Y minus, I will write here, the final solution will be y minus, y by, therefore the solution y by x minus x cube is equal to the solution 1 by 2 into 1 minus x square plus c, which is the required solution of the given differential equation. Just clearly, the equation is in linear form. So, for linear equation, we have the solution y into e power integral p dx is equal to integral q into e power integral p dx dx plus c. So, based on that, we will have y e power integral p dx already we have evaluated the value here entered. Q into e power integral p dx again dx plus c, on integrating we will get the required solution. That is the first problem solution. Now similarly, solve the differential equation dy by dx into 2 minus y secant x is equal to y cube tan x. So clearly it is a Bernoulli form. What is the Bernoulli form? Dy by dx plus p of x into y is equal to q into y power n. So here q, function of x into y power n also there. So to solve the Bernoulli equation, first we have to reduce it to linear form by dividing throughout the equation with y cube. So I will do this. So first, the given differential equation is dy by dx minus y into secant x by 2 is equal to y cube into tan x by 2. So I'm dividing equation with 2. Now, again, on dividing throughout with the y cube, we get 1 by y cube dy by dx minus y by y cube into secant x by 2 is equal to y cube by y cube. So y cube will get cancelled on the right hand side. You'll get what is the remaining term? You get only tan x by 2. Or I can rewrite it as y power minus 3 dy by dx minus this is y power minus 2 secant x by 2 is equal to tan x by 2. Now put y power minus 2 is equal to some u. I am taking the coefficient of this one is y power minus 2, that is u. Then n into a power n minus 1 dy by dx is equal to du by dx. And differentiating with respect to x, the value will become y power minus 3 dy by dx is equal to minus 1 by 2 into du by dx. So, substituting in this equation, what will get y power minus 3 dy by dx minus 1 by 2 into du by dx. So, minus 1 by 2 into du by dx, that is the first term. Second term, minus y power minus 2 means u into secant x by 2 minus u into secant x by 2 u into, this is y power minus 2 u into secant x by 2, right side tan x by 2 is equal to tan x by 2. But on cancelling out 2 throughout the equation and multiply with minus sign, minus 2 on multiplying throughout with minus 2, you'll get du by dx plus secant x into u is equal to minus 2 on multiplying, you'll get minus tan x. On multiplying throughout the equation minus 2, 2 cancel, minus cancel, du by dx. Minus 2 cancel, minus plus u secant x. Minus 2 cancel, minus tan x. That is the equation number 2. Now it is in the form of linear equation. This is a linear differential equation in u. Here P is equal to, what is P? P is equal to secant x and Q is equal to minus tan x. Q is equal to minus tan x. Then e power integral p dx. This is requirement in solution. So I am calculating e power integral p dx. That is e power integral secant x dx. That is e power log secant x dx integration log secant x plus tan x. So e power log secant x plus tan x will give you secant x plus tan x. E power log x x. E power log secant x plus tan x. That is secant x plus tan x. Now the general solution. The solution is u into e power integral p dx is equal to integral q into e power integral p dx plus c. That is u into e power integral p dx is secant x plus tan x is equal to integral, what is q? What is q? Minus tan x. Q is minus tan x and e power integral p dx secant x plus tan x plus c and dx also there. E power integral p dx is e power log secant x plus tan x, that is secant x plus tan x. Now, this is u. What is u? U I will substitute later. U into secant x plus tan x is equal to minus integral, first term, secant x tan x dx, first term. Second term, minus tan square x dx plus c. So, what is integral secant x dx? D by dx of secant x is secant x tan x. Integral secant x tan x dx is secant x. Integral, if d by, we know that d by dx of secant x, that is equal to secant x tan x. So, on taking integration, secant x tan x dx integral is equal to integral d of secant x, that is secant x. minus what is integral tan square x. So that I will see integral tan square x dx. So what is secant square x minus tan square x is equal to 1. You know that. So what is tan square x? Secant square x minus 1. So you can write this as secant square x minus 1 dx. Integral secant square x is tan x minus x. So the value is minus of tan x minus x plus c, or this is minus secant x plus tan x plus x plus c on the right hand side. And on the left hand side, what you have taken, u is equal to y power minus 2. You have to replace u also. So y power minus 2 into this is secant x plus tan x. So this is the required solution of the given equation. Y power minus 2 secant x plus tan x is equal to minus secant x plus tan x plus c, which is this is also a linear equation. So first we get the given equation in Bernoulli form. We transform the given equation into a linear equation in U. Thereafter we find solution by using the general solution method. The final solution is secant x plus tan x by y square is equal to minus secant x plus tan x plus c. That is the required solution. Similarly, solve the another equation. Dy by dx into x square y cube plus xy is equal to 1. So, I can rewrite this as, the given equation. The equation can be written as dx by dy is equal to x square y cube plus xy. Am I right? Or dx by dy minus yx is equal to x square y cube. So clearly, this is a Bernoulli equation in the terms of x, dx by dy. Here there is a x term on the right side that has to be eliminated. On dividing throughout with x square. So what is the general form? Dx by dy plus p of y into x is equal to q of y. This is equation. This is called the linear differential equation of first order in x. The solution will be x into e power integral p dy is equal to integral q into e power integral p dy plus c, where q of y is a pure function of y and p of y is also a pure function of y. So it is to make this equation in this format, just I have to make the right side as a pure function of y only. For that I have to delete x square on the right hand side. So I divide throughout the equation with x square, that is 1 by x square dx by dy minus y into x by x square is equal to y cube. Or what I can write, x power minus 2 dx by dy minus x power minus 1 into y is equal to y cube, and this is the equation, call it as 2. Now put x power minus 1 is equal to some other variable u. Put x power minus 1 like Bernoulli equation solution. Whatever the coefficient of y, that has to be assumed as another variable u. Then n into a power n minus 1 x power minus 2 dx by dy is equal to du by dx. Or what I can write, x power minus 2 dx by dy is equal to minus du by dx, because du by dy, not du by dx, because we are differentiating with respect to y. So n into a power n minus 1 dx by dy is equal to du by dy. So the first term in the equation 2 is replaced by minus du by dy, minus x power minus 1 is replaced by u into y is equal to y cube. So what I have to write is minus du by dy minus, so what I can write, x power minus 1, that is u into y is equal to right side y cube. It is du by dy plus u into y is equal to minus y cube. So this is in the form, what is the form? Standard form du by dy plus p of y into u is equal to q of y. This is in the form of linear differential equation in u terms. This is linear differential equation in u. So what is the solution? The solution is in the form u into e power integral p dy is equal to integral q into e power integral p dy plus c. This is the solution of this equation. So now to find the solution, what is p, what is q? First you have to write here. It is in the form du by dy plus p of y into u is equal to q. What is here? P of y or p is equal to, what is p? The value is y. P is y. And what is q? Q is equal to minus y cube. And e power integral p dy, that is e power integral y dy, that is e power y square by 2. Therefore, the solution is, therefore, the general solution is u into e power integral p dy, e power y square by 2 is equal to integral q. Q means minus y cube, e power y square by 2 dy plus c. So, this is equal to u into e power y square by 2 is equal to minus integral y cube into e power y square by 2 dy plus c. Now to evaluate the integral on the right hand side, you have to assume y square by 2 is equal to t. Another substitution. So to y square by 2 is equal to t. Y square is equal to 2t. 2y dy is equal to 2y dy is equal to 2 dt. 2 dt. Or y dy is equal to dt. Right. So what I can write on the right hand side, it is integral y cube can be written as y square into y. Y cube can be written as y square into y. So y square means 2t. Y square means 2t. Replaced. Y dy is replaced by dt. And this is e power t plus c. I hope this is clear. So just I am replacing here. Y cube can be written as y square into y. Y square is replaced by 2t. And y dy is replaced by dt and e power t plus c. So minus 2 into integral t e power t dt plus c. But what is the formula? Integral x e power x dx. Integral x e power x dx is equal to e power x into x minus 1. So I am writing this is minus 2 into e power t into t minus 1 plus c. Just substitute the formula. It is t e power t, this is x e power x dx. Both are same. So that is minus 2 into t means what? Y square by 2. In brackets also y square by 2 minus 1 plus c. And on the left hand side, what is the left hand side value? The value u into, what is u? U is equal to our assumption. In the previous slide, we have the assumption that u is equal to x power minus 1. So x power minus 1 into e power y square by 2 is equal to this one. Or e power y square by 2 by x is equal to minus 2 e power y square by 2 into y square by 2 minus 1 plus c. So this is the required solution of the given differential equation. Here you have to here there are 3 assumptions. First you have to convert the given equation in Bernoulli form, Bernoulli to linear form. After then you have to substitute u for, finally you have to replace u for that one, and in intermediate case we assume that evaluate the integral, put another substitution y square by 2 is equal to t. Don't confuse them with lot of confusions. Just lot of substitutions. There are so many substitutions. Here one substitution. Finally the equation should be in the terms of x and y only. So that you have to maintain. The final answer will be like that. Right? That is the given solution for the problem. And we go for the last problem. Find the orthogonal trajectories. I think one more problem is also there. Find the orthogonal trajectories of the family of circles. X square plus y square plus 2gx plus c is equal to 0, where g is the parameter. What is orthogonal trajectory? A curve which cuts every member of the given family at right angles is called an orthogonal trajectory. Here it is given x square plus y square plus 2gx plus c is equal to 0 is a circle equation whose center at minus g comma 0. That means it will be on minus g comma 0 means it is on the x-axis, and these are the family of circles. These are the family of circles, and which is not passing through horizon because constant is there. So it is a family of circles. We have to find the orthogonal trajectory. Orthogonal trajectory means a curve which cuts every member of the given family at right angles is called orthogonal trajectory. We know the procedure, just I will perform. The given family of circles x square plus y square plus 2gx plus c is equal to 0. So on differentiating with respect to x, 2x plus 2y y dash plus 2g into 1 plus constant derivative 0 is equal to 0. Or 2g is equal to minus of 2x plus 2y y dash. So where y dash is, y dash means it is a dy by dx. Y dash means dy by dx. So call this is equation number 2, this is equation 1. Substitute equation 2 in equation 1. Then 1 implies x square plus y square. 2g means minus of 2x plus 2y y dash of x plus c is equal to 0. Or on simplifying, what we will get x square plus y square minus 2x square minus 2x y dash plus c is equal to 0. Or what I can write x square minus 2x square. This I can write as a y square minus x square. The equation can be written as y square. I am simplifying y square as it is x square minus 2x square minus x square minus 2xy dash plus c is equal to 0. So call this is equation number 3, which is the differential equation of the given family of circles. Clearly this is the given family of circles. So on eliminating g, because g is the parameter, we should eliminate g. So to eliminate, I differentiate the given equation with respect to x, and 2g calculated and resubstituted in the equation 1. So now we got eliminant of g, that is y square minus x square minus 2xy y dash plus c is equal to 0 is the given differential equation. I will write once again y square, it is y square minus x square minus 2x y dash plus c is equal to 0. Minus 2x y dash plus c is equal to 0 is the given, which is the differential equation of the given family. Differential equation of the given family. Now, for orthogonal trajectories, replace y dash by minus 1 by y dash. That means what? For dy by dx slope, we have to replace minus dx by dy, which is a perpendicular slope. Then y square minus x square plus c, you write as one set, minus 2xy into, so for y dash, replace minus 1 by y dash. Then what is this? Y square minus x square plus c into y dash plus 2xy is equal to 0. Or what this is? Y square minus x square plus c into dy by dx plus 2xy is equal to 0. Or దీన్నే I can write 2xy dx plus y square minus x square plus c of dy is equal to 0, which is equation number 4. What it represents, which is the differential equation of the, which is the differential equation of the orthogonal trajectory, which is the differential equation of the given family of curves. This is. Now, on replacing y dash by minus, this is equation number 3. Now, on replacing y dash by minus 1 by y dash, the equation reduces to this form, equation number 4, and which is the differential equation of orthogonal trajectory. Now, to solve this equation, we go for the m dx plus n dy is equal to 0, exact equation method. Here, what is m? Here, m is equal to 2xy. On solving this equation, we will get the required family of orthogonal trajectory curves. So, what is dou m by dou y? That is equal to, here dou m by dou y is equal to 2x. And similarly, n is y square minus x square plus c, and dou n by dou x is equal to minus 2x. Now consider 1 by n into n or m, 1 by m. We consider, we know the integrating factors models. I am considering 1 by m into dou n by dou x minus dou m by dou y value. That is 1 by m means 2xy, and dou n by dou x, that is minus 2x. Dou m by dou y, that is also 2x. So minus 4x by 2xy, or it is minus 2 by y. It is a pure function of y. Then what is the integrating factor? E power integral g of y dy, that is e power integral minus 2 by y dy, that is e power minus 2 log y, or y power minus 2. So, after getting this integrating factor, we multiply this equation with 4. Now, equation 4 multiply with y power minus 2. Then what will get? 2xy by y square dx plus y square minus x square plus c by y square of dy is equal to 0. Or what will get? 2x by y dx plus 1 minus x square by y square plus c by y square dy is equal to 0. Now it is an exact equation because already this equation is obtained by multiplying the non-exact equation with integrating factor. What is the solution? The solution will be integral 2x by y dx, treating y constant, plus integral the terms of n not containing x terms. This has to be eliminated. So 1 plus c by y square is to be considered of dy is equal to c. So almost we are in final phase of solution. So what is the integration? This is 2x square by 2y, 1 by y constant because we are integrating with respect to x, plus integral dy, y, c into y power minus 2 dy, y power minus 2 plus 1 by, that is minus 1 by y is equal to c. 2 to cancel, x square plus y square minus c, this is put k, the k is another constant, is equal to k into y, because y is the LCM on the right hand side, left hand side. So y on taking outside, x square plus y into y square minus c is equal to ky, or this equation represents a orthogonal trajectory of the given family. Clearly, it also represents a circle equations with the centers on y-axis, 2gy, x square plus y square plus 2gy plus c is equal to 0. So, these are the orthogonal trajectories of the given family of curves. So, now I will give the idea to this problem when you solve this problem. A body kept in air with temperature 25 degrees centigrade cools from 140 degrees centigrade to 80 degrees centigrade in 20 minutes. Find when the body cools down to 35 degrees centigrade. So this is the application problems of Newton's law of cooling. So what is by Newton's law of cooling? The rate of change of temperature with respect to time is directly proportional to theta minus theta naught, where theta naught is the medium temperature. That theta naught is the medium temperature. Then what I can write, d theta by dt is equal to k into theta minus theta naught with negative sign, where k denotes that the cooling effect of the body. Because we are getting cooling effect. Initially it is 140 and it reduces to 80 degrees means the body getting cooling effect. That means you have to put the minus symbol here. If it is plus symbol, then it increases, it denotes that increases of the heat. So our d theta by theta minus theta naught is equal to minus k dt on separating the variables. And on integrating log theta minus theta naught is equal to minus kt plus c. Or you can take log c also. So log theta minus theta naught by c base c is equal to minus kt, or theta minus theta naught by c is equal to e power minus kt, or theta is equal to theta naught plus c into e power minus kt. This is the relation from our formula. The relation is theta is equal to theta naught plus c into e power minus kt. So this is the relation obtained by the Newton's law of cooling. Where theta naught given, what is theta naught? Given theta naught is 25 degrees Celsius air temperature, that is medium temperature. Therefore theta is equal to 25 plus c into e power minus kt. So this is the relation. So now we have to find when the body cools down to 35 degrees centigrade. At what time, at what time theta will be 35 degrees centigrade. That you need to calculate. That means what? You need to get a relation in terms of theta and t. So to get the relation in terms of theta and t, we have the initial conditions. What are given? When t0, initially when time 0, the temperature of the body is 140 degrees Celsius. So after 20 minutes, t20 minutes, the theta reduces to 80 degrees Celsius. These two are called the boundary conditions. So in substituting, you will get two relations. Suppose if we substitute first relation, so I'll write in the next slide. Given theta is equal to 25 plus c into e power minus kt. Am I right? So when t0, theta is equal to 140 degrees Celsius. So on substituting, 140 is equal to 25 plus c into e power minus k into 0, or 140 25 means 115 is equal to c. So we obtain c value. So on substituting this, theta is equal to 25 plus 115 into e power minus kt. This is the new equation after finding the value of the constant c. Now we have another relation also. When t is equal to 20 minutes, the theta reduces to 80 degrees, I think, 80 degrees Celsius. On substituting these also, 80 is equal to 25 plus 115 e power minus k into 20. Or 80 minus 25, that is 55. Am I right? 80 minus 25, 70, 80, that is 115 into e power minus 20k, or e power minus 20k is equal to 55 by 115, or on taking, or this is 5 11s, 5 2s 10, 5 3s 15, 5 2s 10, 1 5 5 3s 15, that is e power minus 20k. So on taking log both sides, minus 20k is equal to log 11 by 23, or k is equal to minus 1 by 20 into log 11 by 23. This is the k value. Then what the equation will get? Therefore, theta is equal to 25 plus 115 e power minus, what is k value? Minus 1 by 20 log 11 by 23 into t value, or 1 by 20, 25 plus 115 and e power, what you will get here? Minus minus plus, and 1 by 20 log 11 by 23 into t. So this is the relation which is obtained in terms of theta and t, which is obtained for theta and t. It is a relation. It is a relation. We call this equation number 4. It is a relation in between theta and t. Now what you have to calculate is here, when theta is equal to 35 degrees, what will be the value? So from this, when t is equal to 35 minutes, what will be the theta value? I think right? Sorry. When theta is equal to 35, when theta is equal to 35 degrees, when theta is equal to 35 degrees, finally what is our aim is when theta is equal to 35 degrees Celsius. So what is the t value? So what is the t value? That is our question. So just replace theta 35. So I'm substituting 35 is equal to 25 plus 115 e power 1 by 20 or t by 20 log 11 by 23. Log 11 by 23. So 35 minus 25, 10. 10 by 115 is equal to e power t by 20 into log 11 by 23. So I'm taking log both sides. Log 10 by 115 is equal to log e power x, that is t by 20 into log 11 by 23. So t is equal to 20 into log 10 by 115 by log 11 by 23. So which is the t value? T means time. So at that time, the theta will be the 35 degrees centigrade. And you do calculations by using calculator. What is the t value? Perfect. In minutes that will come finally. So with these few problems, I conclude my. And this is the reference is the question bank of the course Differential Equations and Vector Calculus for the BT23 published by IARE. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.